Hello and welcome to our climate exhibition during British Science Festival 2023. This year, we've worked with lots of communities and groups to make our exhibition even bigger and better than last year. We're going to take you on a journey across the cosmos and back to Earth. To begin with, we're looking at exoplanets. How do we detect them, and how can we find out more about them?
So exoplanets are normally found by something called the transit method, where a planet crosses in front of a star and some of the light from the star dips down. Whilst this might sound like quite a hard thing to do, it is, but we can also find out information such as about the atmosphere of the planet by transmission spectroscopy. So if you come and visit the exhibition, you can have a go at your very own spectroscopy safari, where you can put on one of these very fun glasses or use a spectroscope. We can also do things like use coronagraphs to help us find planets, which is where we block some of the light. We block all the light from the star, and because stars are really bright and big and planets are really small and dim, by blocking some of that light, you can have a go at finding your very own little planets. Now, doing this with our own human eyes in the visible light is quite difficult, so a lot of the time when we're looking in space, we'll use infrared light. This gives us a lot of information on things like temperature, so you can have a go at finding the hidden hot thing. And temperature is a very interesting thing to use in space because we can use things like temperature or colour when we're looking at stars, because this tells us things like how far away something might be, what its atmosphere might be made of, and surface conditions.
So when we find these planets, we want to understand what their atmospheres are like. And one of the things we can do is to understand that better, is to look at something called fluid dynamics. And this is a really lovely demonstration. This is called a kaleidoscope. It was invented by an artist, and it's a way of being able to see how fluids like the air, fluids like water, see how they behave. Because normally we can't see these beautiful currents, but when we make this special fluid, we can. And the Earth is a spinning system. And so we really want to understand, how do fluids behave in a spinning system? And before we had fancy supercomputers to help interpret that, people used things like this. And so this is just really beautiful, and you can compare what you see in here to some of the beautiful storm images that we have over here. So this board really shows us all about how physics is the same everywhere. That's one of the reasons that we can use the same models to understand Earth as we can to understand other planets, because we see the same features all over the universe. So here we've got pictures of in each set there's a picture from Earth and there's a picture from another planet, and you have to guess which one's which and see if you're right behind the flaps. So yeah, we see craters, we see storms, we see lakes, we see big canyons and extreme environments. We see that on Earth, but we also see it elsewhere in our solar system. So over here, you can look at some of these climate models that I was mentioning. So there's a load of amazing people in the University of Exeter and the Met Office who are working on these fantastic climate models to better understand our climate and the climates on other planets, and also the potential future climate. So you can compare different planets here, you can drag them up, you can compare Earth from the past with the current Earth. Whoops. And you can compare different things about them, like the amount of rain, the amount of cloud. And this is just a really lovely way of visualising what these climate models are doing. If you come over here, we've got a wonderful VR film that goes through 6 different exoplanets, so planets going around other stars, and what it would feel like to actually be on them. And it uses real data, our real understanding of what these planets might be like, and it's a really wonderful, immersive experience. Brilliant.
So it's clear there's some amazing planets out there, but could we ever live on any of them? Probably not. In the worlds of Carl Sagan, this is the only home we've ever known. It would take Voyager 1 74,000 years to reach our nearest exoplanet. And even if we could reach another exoplanet, it would be too different to our own. And we've demonstrated that here with our mirror exhibit, to show that if you sit opposite someone, you'll notice that there are many differences, despite the fact that you share 99.6% of the same DNA. So in conclusion, there is no planet B. We have to look after the one we've got.
now we come to our wonderful archway here that's lush and beautiful and reminds us how special the earth is. So you really feel you're coming into this other zone. So into here, it's welcome to Earth. This section is all about treasuring Earth, understanding it better. Now we've seen the sort of extremes of these other worlds. And here we've got a fantastic video. This is an award-winning VR film. And it's all about how we observe the Earth from space and what we understand about the intricate ecosystems and how everything is connected and our actions really matter. So that's a really enjoyable experience there. And then we come into the Earth's climate zone here.
So Earth's climate is an example of a chaotic system. So chaos isn't random, it's just really, really hard to predict. This is illustrated here with our double pendulum. If we set these two going at the same time, we'll find that initially they behave the same. However, as time goes on, tiny differences in the initial conditions increase into a larger perturbation. We're also trying to show off some of the amazing research that happens at Exeter University. For example, there's a scientist who puts on this flotation suit, uses this net to capture plankton, and then place them in this plankton wheel to study them for carbon sequestration. We're also really, really interested in using green spaces to help cool Exeter in a warming world. And it is clear that Exeter is warming, as demonstrated here by our climate spikes. This is the temperature anomaly relative to 1951 to 1981. And as we can see, in recent years, we've got a massive amount of warming. We can also find warming evidence in observational data, like in tree rings. But all hope is not lost. There is lots of things that we can do to take positive action starting right now.
So come on into our action zone and find out what an impact you can make as an individual and collectively in society, in your communities, at work. What can we do to make the biggest difference? And we show some really lovely inspiration from local action groups who are doing great things across the region. Including how we might emulate what beavers are doing in rivers and streams to try and slow floodwaters. We also highlight that there are many ways that we can make a difference, and some of those differences might lead to even bigger changes in society when we work collectively as a society, and also our industries and our governments make a big difference too. So we demonstrate that with our positive tipping points demonstration, and we try to move from a high carbon current state in society to a low carbon future state, such as, for example, in electric transport. What can we do? What changes can we make in society to make a difference, to move to a low carbon future state? And when you visited this section, we ask everybody to make a pledge. What could you do to make a difference in society? What would you pledge to do? Write down your pledge, grab a block, pop your name on it, and add it to our Tip the Scales exhibit. And if your action doesn't make an immediate change, you don't see the immediate effect of your actions, don't worry. That happens. And what we need is we need more people to come in, maybe make another pledge and add your pledge to the scales, and maybe your pledges collectively will tip the scales. And it doesn't end there. We want to highlight that there are loads of ways that you can make changes. You can create change through your actions, through your collective thinking. We ask everyone to contribute to our daily mural. This is what is your vision of a positive future today. and we ask you perhaps to plant seeds of change and make newspaper plant pots. Even a small symbol like this, taking a little plug plant of local or native wildflower seeds, can make a huge difference if collectively we all do this and perhaps make more of a space for wildlife in our gardens and our window boxes. No matter how much space you've got, you can always make a difference. So we hope you've enjoyed your visit to our exhibition. Grab a leaf, tell us what you would like to see in a future science centre and what you've enjoyed today, and add to our tree of hope. We want to get your views, and we want to see you at the Future Science Centre and make it with everybody's ideas. Thank you so much for visiting.